Astronomers previously thought the universe was infinite, but Einstein's general relativity showed our universe actually has a boundary. It's just that this boundary exists in higher dimensions. Before discussing the universe's boundary, we must first understand boundaries within the universe, from the solar system to the Milky Way, to the nearest large and small Magellanic Clouds, and the Andromeda Galaxy 2.54 million light-years away. These independent and closed celestial systems all have clear boundaries. The void of several light-years between stars, and the void of millions of light-years between galaxies keep them well separated. However, in Einstein's view, since universal spacetime belongs to three-dimensional space plus one dimension of time, the entire universe at the macroscopic level forms a closed four-dimensional hypersphere structure. In this case, the universe is undoubtedly bounded. Flying out of the hypersphere means leaving the universe. However, while being bounded, the universe is also borderless. That is to say, flying a light-speed ship in any direction will eventually return to the starting point. The pilot thinks they're moving straight up, but in a closed universe, geodesic lines are themselves closed curves, unknowingly returning to the origin. This bounded yet borderless universe model actually is like humans circumnavigating Earth, moving straight ahead, yet returning to the starting point. Similarly, to see Earth's full appearance, you must extend from the two-dimensional ocean into a third dimension, flying vertically upward from Earth into space. Only then can you see the entire Earth and experience Earth's bounded yet borderless nature. Therefore, for humans to see the universe's bounded borderless nature, we must first open a new direction from three-dimensional space, or a new dimension, then travel at light speed or faster in the new dimension. Only then can we escape our closed hypersphere universe and enter higher dimensional spacetime to see individual universe bubbles. According to parallel universe theory, our current universe is just one of several parallel universes. In the vast hyperspace exist countless universes. Each one is the product of a Big Bang. Different universe bubbles have different universal laws. For example, in our universe, light speed is 300,000 kilometers per second. Other universes might have light speeds of 30,000 or 300 kilometers per second. However, with humanity's current technology, discussing universe boundaries is far too premature, because even the most powerful telescopes cannot see the universe's boundary. We can only roughly guess its existence. Currently, within this observable universe of 93 billion light-years diameter, humans have observed only 2 trillion galaxies, plus dark matter and dark energy. Regarding the universe's most macroscopic appearance, we remain completely in the dark. In the sci-fi movie Men in Black, the Milky Way, 100,000 light-years in diameter, is merely a marble on a cat's collar, and such marbles are just game pieces for advanced alien civilizations. Perhaps we will truly discover that our entire universe is just a microscopic particle in a higher-level macroscopic object. In this scenario, our universe might be just a small part of an even larger universe. Like Russian nesting dolls, one inside another, the universe might be contained within a grain of sand. This grain of sand might lie on a beach of an unimaginably vast world. Perhaps intelligent civilizations from other dimensions are observing the Sun and Earth right now, just as we observe electrons and protons. In summary, the universe remains the greatest puzzle for human civilization, and questions about its boundaries will certainly be discussed repeatedly in the future. However, no matter where the universe's boundary lies, no matter what it conceals, we must not forget, human civilization was born on Earth.